Good morning. We will wait just a couple more minutes. We're seeing a lot of attendees are still flying in, so we'll wait about 30 seconds and then we will start this. Okay, let's get this show on the road. Good morning to all of you out there all throughout the world. We're happy to have you join with this next Tebis webinar, this time about the powerful capability that Tebis has in terms of gun drilling and deep hole drilling. Truly, this is an honor because we have people from all across the world connecting us, people that are in Sweden. We welcome you, as well as in the UK, our friends, Germany, Spain, Turkey, US, and Mexico. We thank you all for joining us in this particular webinar. My name is Michael Thiessen. I'm the moderator of today's webinar, and I'm joined by my good friend and colleague, Mr. Greg DeRitter. Before we start, let me get a couple things out of the way in order to make this more enjoyable for all of you guys, in order to help out with the bandwidth issues, because we're all working from various different places all around the world. What Greg and I will do, we will turn off our webcam when we get started with the actual meat and potatoes of the webinar, and we will turn ourselves back on again once we get towards the end, when we deal with your questions that you're bringing in. If you should have any audio issues or you have any additional issues, there's also the audio option where you can connect via your phone, utilize the telephone number that is in your registration form that you received, and connect via that, but hopefully everything will be without any glitches. If you should have any questions, and we encourage you, if you have any questions throughout the webinar, please put it in the question box on the right side of your panel. We will go through all of these questions towards the end of the webinar, and hopefully we will be able to get to all of your questions that you are getting to us through this. A little bit about us. Again, my name is Michael Thiessen. I am the sales manager here at Tebis America, dealing with all sales-related items in Canada, as well as here in our United States. Our headquarters in the US is in Troy, Michigan, and this is where we're operating out of this office throughout the entire US and Canada. Greg, why don't you introduce yourself a little bit?
How we doing, guys? My name is Greg DeRitter. I'm a product and application specialist over at Tebis America. I've been with the company almost 6 years, and I have a previous experience with mold and die work, some small manufacturing, small part manufacturing, things like that. Definitely work very well with the software with a few different companies as far as this new product goes. And frankly, it's amazing. So I'm really excited to show everybody how it works and how you can utilize it.
Perfect. All right. At this point in time, what we will do is we will turn off our webcam so you can actually focus and enjoy the webinar. Don't have to look at two ugly faces staring at you. So with this said, let's get started and go into the entire operations of deep hole drilling and gun hole drilling. All right, a little bit about the history of Tebis. For some of you that know Tebis quite well, you know of the history of who Tebis is. For some of you that are fairly new with Tebis, this potentially is a new experience for you. Tebis has been around since 1984 with our two founders, Mr. Bernard Flintfleisch and Mr. Hahn, starting the company in 1984. And I'm proud to say that this year marks our, here in the US, 25th year anniversary. We started in 1996 by Mr. Gerardo Miller over here in the United States, and ever since we've been operating out of our Troy location. And as you see, all the way through our current state, of course, the last state is 2018, but trust me, there were many more milestones that happened between 2018 and today's state. Just to give you a little bit of an idea, Tebis is not just a German company based out of our German headquarters in Germany with all of its subsidiaries. Tebis is a worldwide company. We deal mainly with our sister companies, our subsidiaries here in the US and Tebis America, our friends at Tebis UK, Tebis Scandinavia, and so forth. And we also have, of course, various different distributors all throughout the world in China and Russia and so forth. So we can really say that we are a global company, global CAD/CAM solution that can cover all of your manufacturing needs, not just the deep hole drilling or not just the 3D milling. It is truly a full CAD/CAM solution. The various different sectors that we are in, of course, we're in the mold die, that's what we're mainly known for, but also in the aerospace industry, in the mold making industry, as I've already said, as well as the medical industry. Just to give you a few little bit of ideas of where we're all involved in, if it is electrode creation. And in this particular webinar, of course, we're dealing with deep hole drilling or gun drilling applications, which of course is majorly involved in the mold environment, but also in the die environment with hot forming dies and so forth, where you have to put coolant lines inside the molds. So just to give you that, all the Tebis programs that we can create come directly out of our software that we develop inside of our system. And this deep hole drilling is no different than any of the other modules that we have. It is developed in our own house in near Munich, Germany. And with this said, I will hand it over completely to my expert, Greg DeRitter, who will guide you through of how easy it is to really utilize this particular tool within Tebis. And hopefully you will enjoy this. Greg, please take it up.
All righty. All right, guys. So I want to just start off by saying a lot of people are going to look at this and they're going to think, okay, this is a big process here. You know, water lines and molds has always been, okay, let's try to make it as simple as possible. And I really do think that Tebis is capable of doing that. It definitely is, with the utilization of like different features and different parametrics inside of the software. So I'm going to show you guys how that works a little bit here, and I'm very excited to show you. So let's go to the next slide here. All right. So Tebis is going to utilize AutoMill here to create different items for our not only automation, but different standardized processes, such as digital twins, such as virtual machines. We can also implicate the virtual tooling here, so we can collision check the full tool, the cutter, the shank and the holder, all the way to the head of the machine, as well as the limits. We also have virtual units, but they're such as like clamping devices, FCS, risers. We can draw those in the software, and you're able to fully set up your part very, very easily. We have customized post processors that we're going to create, so we can handle any sort of controller, most controllers that are out there for different styles of machines. So maybe your machine doesn't have a standard controller, but that's no problem here for us. We also work off a very templated system. So different items, what we're going to call as features here. So features essentially are going to stretch over the part to any sort of water line that might be here, water line, ejection lines, vent holes, things like that. And we're going to make these variable so they can fit a wide variety of different sizes. And then this is going to hold the smarts to where if it sees a little hole like this, it's going to see a spot face. It's going to see maybe it needs to put in a spot drill, maybe a drill, Maybe if it's longer, it'll put in a gun drill. We're going to do this what we call an NC set. So what an NC set is going to be, it's going to be a grouping of tool paths here that we create ahead of time that's going to take a look at the feature and they're going to be connected. So now if I run a feature, it'll actually run an NC set in the background, and this is going to hold a lot of your variables to where maybe I want to switch over a machine and I want to switch the process a little bit. Maybe the strategy changes, the tooling might change, different holders, things of that nature. And then we have NC templates for similar machining tasks. So essentially what this is saying is I'll bring in a templated file here that's going to allow me to maybe pick a different head. It's going to run a different feature automated program here, or maybe I want to run specific static tools in here. I could even put in there as well, but we're going to focus a little more on the automation side of things. So I want to go back here and discuss one more thing here. For the NC documentation, we also have templates that you get in the software when you download it for NC documentation, where it'll show the setup of the machine. It'll give you your G54 or G55 numbers here, so you can easily check that back to the machine, as well as having a nice tool assembly list. So if guys are on the machine, they're setting up tooling, you can give them a nice picture with some information. Makes it a little bit easier on them. So I'm going to go back here. We're going to discuss these NC sets just a little bit further before we really get started. So exactly what is an NC set? As I've said before, it's more of a grouping of tool paths that we create ahead of time that we can use in the future, and then I can keep using them. So the whole point of this is to standardize your process. It's, you don't want to be repeating yourself, programming the same thing over and over again. So if I create these NC sets ahead of time, then I'm able to standardize my process a little more. We can make as many of these as we need to. But this is what it's going to look like. Right here is a library for it. All right. And the first thing it's going to ask for is for your tooling. So we're looking at a variable tool description. What that's going to do is it's going to search your tool library. It's going to look for the right tool. Okay. It's going to look for the right size tool as well, which is going to help optimize what I'm using. It's going to make sure that the tool's not too short, but it's also not going to grab the longest guy in the drawer there. It's going to make sure that it optimizes it and grabs something that will fit, but that's also optimal for you to run. It's also going to look at the different entities here. So talking about the features a little bit, which I'll get more into, this is actually going to stretch across your features here, where you're going to see the different shape, if it's a through hole or if it stops. It's going to look at the diameters, it's going to look at the depths, and I'll get a little further into this depth table too, of how simple this really can be. Basically, you're letting the features do all of the work for you. Once you automate those features in, then you're pretty much there. It's really, really simple. So if I look at that depth table, it's going to show me the material area, the gap area, things like that. Then I can really easily just kind of go back and switch it if I need to. And then this is going to be your strategy panel, where you can go in and you can really fine tune what you want to do here. Maybe you want to adjust how it starts from the very beginning. Maybe you want to change how it's looking at those cut sections. So a cut section is more or less going to be a water line for a mold. And that water line is going to be passing through another water line that was already previously drilled. So as it passes through, if some of you guys maybe you know or you don't know, you need to speed up and slow down that drill, right? A certain amount. Maybe you want to put a ramp in there, ramp the speeds and feeds down, or maybe you just want to ramp the feed down. It really just depends, but we can really fine tune that here, which is really nice. All right, so let's just talk about some of the configuration settings that we have here and how easy it is to use, right? This is, like I said, it's more of a set it and forget it. You creating something in the beginning to use for till the end of time, right? You're creating something that is, okay, this machine maybe is set up a certain way, but I don't know, I don't really want to run it this way on this other machine, so I'm going to set up a different configuration setting. So just to kind of look here, We got it, our configuration. This was actually added recently with our latest update for gun drilling water lines and such inside of Tebis. But you're able to really fine tune everything in here. So you can have different machine setups for different operations, different materials, and you can get very exact, which is something that we were looking to do here. So if you want to, you could say, I have this gun drill. It's maybe an an inserted tip, or this one's a conventional style gun drill. I want to run it, let's say, I don't know, 2,000 at 6 inches a minute. But then when I slow down, I want to slow the speed and feed down. I want to slow it down to maybe 1,000 RP, 1,000 spindle speed, and then maybe, I don't know, like 2 inches a minute. And you could do that for that gun drill, but then you could also insert another value for another one. And then this is that depth table I was talking a little bit about, where it'll give you the exact depths based on those feature cut sections, which I'll get into. To where it'll say, at 50 millimeters deep, that's all material. But at 60 millimeters deep, there's a gap there. But really, you could just go through and switch it back and forth. So even if, oh, there's not really a line there, I don't want it to slow down, you can just switch it. It's really, really easy. All right, so just a little bit of a tip and trick section here. With my experience working with these different style machines, we worked with IMSAs, Taurus machines, or gun drills. We worked with Jetto gun drills, things like that. And for the categories of Worksteps, it all really kind of comes down to the same bona fide items here. And the first thing I'm going to talk about is a work step. What is it really? You see two of them here that I created: deep hole drilling and preparation. This is more or less if you have gun drills and boring mills inside of the same shop, and maybe you want to run a gun drill a little bit differently on a gun drill than a boring mill. So on a boring mill, you could set everything up in one automated process and kind of standardize everything. And you can run a preparation set, which maybe will only run your 2D, and then you can run a deep hole drilling set, and that's only going to run your gun drills. So like I said, just a little bit of a tip and trick here if this is something you're interested in. And then this right here is going to be the categories that I would typically recommend. Most of the time, if I'm going to a shop here, I'm going to see guys using both styles of gun drills. Some guys are going to use inserted gun drills. Some guys are going to use conventional. So typically, I'll go through and make a category for each, for conventional style and inserted. This is just going to help separate my speeds and feeds very nicely and make everything a little bit easier to use. All right, so now we're going to start talking more of a practical example here. So you got a couple items like your general preparation, your first NC machining, second NC machining, third NC machining. So it's just really the process. So what's the first step, right? I open up a job, it's been designed, it gets sent to me. What's step number one? Step number one is going to be the generation of features, right? I need to create all the features. So for some of you that haven't really worked with a feature before, really that's just going to be an overlay of the water. For right now, we'll just talk about the water lines, but it's an overlay of the water lines that are there. So it's going to have all the parametrics there. It's going to point to all the correct tool paths. It's going to pull all the necessary data that I need. So let's see it here. And as you can see here, this is just going to be this mold insert that I'm going to be working with. And first thing I need to do is do a little bit of prep work. So I'll actually show you how to do this really quickly. You can use a top remove function, which is our function to actually separate the topology a little bit. Very, very useful. And for right now, I'm just going to go based off of the colors. If you're not using colors, there are other items that you can use, like tangencies and whatnot. But I'm just going to pick the colors here. And then I can actually separate very easily the water lines from the part itself. Not something that you necessarily have to do, but very highly suggested, because now it's going to make the whole process much easier, and you're not looking at the whole block wondering if you got everything or not. So just to help simplify it a little bit. So now I'm going to use the scan function here, feature scan, and I'm actually going to scan over all these water lines, and I'm going to let Tebis automatically pick the correct feature here. So I got 0 out of 37 inserted, so it's going to tell you how many I got. if you just pick auto here, it should stretch that feature all the way across to where it's going to insert all of your features for you. All right. So now I got the block, it's designed, and I was able to easily, quickly insert all the features. It could be that simple. We have another option here for extending. So typically what this is, which I find it to be really cool personally, I wish I would have had this, back when I was programming the Gundrills for the Gundrills. But what it is essentially if your block is a little bit bigger than the part itself, maybe you went and you picked up a raw block and you need to put some spot faces on there so that Gundrill seats off properly. We can make this really simple. So essentially, if you take a look here, the stock model is actually a little bit bigger than these features. It's a little bit longer. So obviously you can't start, the starting point of the feature would be here, so you can't run it down into the block, right? You'll crash it. So I'll pick the stock model and then I'll actually scan all the features. And you can set up different types. But as you can see, it's going to automatically pull those features right out to the edge of the block here and then insert a spot face as necessary. It'll also insert a little counter bore too, which is kind of cool. If you got like a tap extension or something, that way it fits nicely in there. All right, so now I made sure I got all the right features. Maybe, like I said, I have a raw block, or maybe I do have a finished block and I don't need to worry about that. It just really depends. So the next step is going to be, how do I want to sort this? I really do think organization is key, guys. You start working with the very complicated block. If you don't organize it in the beginning, it could always be a little bit of a nuisance here. But so if I take a look, Tebis has a great sorting option, right? And I could put it on a certain layer, and it'll automatically sort everything per direction. So I can see what's coming from the top of block, what's coming from the side of block. Maybe I want to be a little more specific. Really simple. All right, so I created a feature. Maybe I got a raw block or something. I need to add a couple spot faces. I can do that really easily here and then sort it up. So really, this process is super quick. So the next step is going to be to program it, right? Maybe I want to run like a template, maybe just for the backup block. This is going to be if you're not utilizing our cut and group section. So if I click this, you can see that I'm just going to quickly import a TXF file here. Some of you maybe have been using templates for a little while now, so you might understand this, but realistically, what I'm trying to do is just standardize the process. I don't want to have something programmed manually every single time. I don't want to repeat myself. So I'm going to go back in. I'm going to make sure I've got the correct pickup on the block here. Once I got the correct pickup, it already has all the toolpaths in there. And then I'm just going to kick this off. So once I kick it off, it's going to run everything that's needed. Maybe it'll skip some things that it doesn't need to, which is also kind of nice. Maybe it doesn't need to do everything, but my goal here is really just to maybe do a little bit of machining. Like as you can see here, it'll do a little bit of maybe rough on the back of the block if it needs to. And then it'll go through and it'll gun drill the water line. So you can see right here, this is going to drill everything as necessary. So within no time at all, I was able to go through, create features, extend them, do what I need to do, and then I could create toolpaths. I could kick the machine off pretty quickly, and I didn't really have to look at any tooling. I didn't have to go through and adjust any parameters. All that stuff is set based off our feature and NC set system. So you can see here, it's automatically going to load the bushing, the correct bushing. It's going to load the gun drills, and then I'm going through and I'm going to drill everything that's needed here. We kind of skip through this a little bit. You can actually see if it has to too. This is just the straight work, but then maybe it goes through and does a little bit of a tilt. So this gun drill just has one head, right? All right, so what happens if you get a block and you're really not sure what bushing to use, or maybe you just want to, test a couple things out here. So we have this option. We have this option here for planning. So if you look here, this is an angled spot face. Maybe I just want to get an idea of what I'm doing, what I'm using. Maybe I got a couple different bushings. I know some shops will have a whole drawer, right? Maybe if they go on the lathe, they create different size bushings. Maybe they create different extensions. So that's really what this is for. I'm going to pull in the tool. I got the gun drill head loaded. So just grab sort of a longer tool if I can, something decent. And then you want to make sure you pick what's called a unit. All right, so the unit is going to be all your different bushings. This is something that you can add to the virtual machine. So I'll just pick a short guy here to start. And then you can adjust everything else as necessary. So you can see I could draw the drill back. I can move it around as needed. I can get some good numbers right away. And then what's pretty cool about this is now that I'm utilizing our feature technology, I can actually pick that feature right away and it'll jump to it. So as you can see, if I jump to that, my bushing's going to crash, right? So that one's no good. I can't use that. So I can go through, go back to my units, and then I can readjust. And I could pick a little bit of a longer bushing here. Can actually draw the gun drill back into the block a little bit too, just if you want to see if it's going to air out on your hit a length, possibly maybe with that longer bushing, which is really nice. Just reselect your feature, and then you can see I've got the clearance necessary. So now this, I know for this instance, that's going to be the bushing that I want to use. All right, so let's get into cutting and grouping the features. So if I'm going to be working with a like more of a user-based sequence here, which is really nice with Tebis, I could go through and I can actually sort my features and I can cut them. So some machines don't have this functionality, so we need to do it in the software. And you can figure out what side you want to machine first. I could pick that side of features. Like I say, this will be my second side I want to machine, and this is my third. And as you can see, it's now going to add those cut sections to the feature. So those cut sections in Tebis are going to be called a gap. Okay, and as you can see right here, that's where the gun drill is going to speed up and slow down. You're giving it a user-based sequence to say, hey, when I cut this side first, this side second, this side third, this side fourth, I want Tebis to know that it's already done. I want to go through, speed up, slow down the gun drill properly, and I don't want there to be anything missed. So at this point, if you'd like to, you could just group everything together. Maybe you have a rotary table on your machine. And if you do this, it's just one selection. You just pick it and go, and you just run your program. So it'll run all the cut sections correctly. What's really nice about this too in Tebis is if you don't like the way this was cut, or maybe you're not happy with it, you could always go back and you could say uncut and then recut it. And what I mean by that is not like cut a job, but more or less create those gap sections again. And maybe you can eliminate what's there, and maybe if you want to start over a little bit. But as you can see here, now this is more of an automated process where it's going to go through and machine those features that are there. You can see it's properly speeding up and slowing down the gun drill as it hits those different cut sections. And because we created our user-based sequence, Tebis is already going to know. You see I got a cut section down here, so it'll speed up and slow down the drill as necessary. But Tebis is already going to know what's been drilled and what is left to go because of that user-based sequence. And it is kind of nice that that's a user-based sequence, because maybe sometimes they set up a job on the table and they're not really sure, okay, well, I set it up with the side facing the machine head. I need to group this a certain way. So now you're able to group those a certain way and then make a couple changes if necessary and go from there. All right, so this is going to be if I program on a gun drill, and surprise, it's going to another machine. So maybe it's going to a boring mill machine and we need different tooling and such. So if we take a look here, we're going to switch our machine over from a gun drill to more of a grobe style machine. So this was already previously programmed here. I'm going to switch it over to a grobe. All right, I'm going to switch the heads over to a Grove machine. You always want to double check your setup. I highly recommend doing that. You always want to double check your reference as well. And then we'll kick it off. So once we kick it off, because of our automation that we set up and the standardization that's here, it's actually going to go through and adjust the process. What I mean by that is because now this is going to more of a boring mill style machine. It's going to add things like a pilot hole. It's going to, maybe you need to helix mill a couple items out before you could put a gun drill in there because you don't necessarily have those whip guides to hold everything in place. So now that I was switched over the machine we have something called machine groups, and that's going to allow me to change that process very, very easily. So let's go to our next set. So let's talk about just generating original features here. Essentially, what we're looking at is maybe I want some 2D. This will be more of the work step area, or maybe on a boring mill machine, we need to machine the 2D here first, and then maybe we'll put in a different head or whatnot for the gun drill style machine. So we can see that, maybe I want to switch up the work step a little bit, just do a little preparation. And then I can go through and I can update the stock model in case maybe it's going like I needed to go take a CMM or to double check it or whatever it is I need to do here. The last thing that I'll discuss here in this slide is going to be the multiple head simulation. This is fantastic. It's absolutely fantastic. I couldn't say anything bad about it at all. What we're doing here is we're actually looking for a gun drill that has a gun drill head, and on the side of it, it's going to have a milling head. So the problem that a lot of people have is like, well, I want to simulate everything and I want to double check it and I want to make sure, well, what if I have a tap tool in the milling head and how do I go about that? So if you take a look here, you can see that I'm fully simulating a dual head gun drill. And I'm going to load in a bushing for the gun drill here. And then now it's going to switch back over to the milling head, come over and pick up a milling tool from the tool changer. And I now have the bushing and the milling tool running at the same time. And as it's running, maybe it needs to go back to a gun drill. And as you can see, that previous tool that's in that milling head there is still in play. So you can collision check against that. You can make sure that it's not going to hit the job. It's not going to hit the table. You're not worried about it. This kind of gets more in the talks of a lights out machining style here. And then as you can see, as it's running the milling tool, the gun drill bushing is in place. So I'm able to collision check against both of them. Definitely run them. Very easy to use. It makes the whole process just a godsend, honestly. So just to kind of reiterate a couple things, you have your digital twins, your process libraries where you draw everything up, you have your tooling, you have your machine. You're going to have your different units like vices. You could put vices in there. You could do FCS, which is fantastic. And then you're going to program everything, simulate it, and then the operator or the NC programmer can really easily go in there, look, double check what he's doing, feel confident about it, and then get it to the shop floor so we can get it machining. So the whole point of this is to make gun drilling a very, very simple process. Put the features in, or scan the block, put the features in. Maybe you want to cut them a certain way off a user-based sequence, and then run them through our job manager, post them out, get them to the floor. All right, so it's essentially what we're talking about here. We just have the whole process, detect it, generate features, specify it, start the automatic processing, which is going to be running your job, and then simulate it, check it. The simulation is definitely key in this too, especially if you have a single head gun drill or maybe you have two heads. You want to feel confident for it getting out to the machine. So at this point, I'll hand it back over to Michael to see if you guys have any questions or you're interested in we can go from there.
I should turn on my microphone as well so that you can all hear me. Thank you again for going over this exciting topic. Hopefully, all of you thought it was very easy to use and very powerful. At least from some of the questions that I've received, there definitely is quite a bit of an interest when it comes to deep hole drilling and gun drilling. So let me start off with a very interesting question. It said you have shown simulation throughout this some of these videos. Is it really checking everything inside this gun drill? Greg, maybe you can answer that question.
Absolutely. And yes, it is. When you are running a simulation, if you have a virtual machine, it's going to check everything from the limits to every piece of geometry that's drawn up inside of that machine. So if your head, and typically there's a 10 millimeter buffer there. So if your head gets within, let's say 10 millimeters of the table, it's going to tell you, hey, you're within 10 millimeters. Are you sure you want to post this out? But yeah, the very simple question is yes. It's definitely, it's one of those items where once you start using it, you really don't want to go back to not using it.
Right. If I can add one more thing to it too, Greg, you showed bushings, you talked about also vices. All of those entities that are inside this machine are actually collision checked. And the interesting thing is it's not just the tool path that gets collision checked, but also all of the movements in between, because most of your machines, if you have newer style gun drills with rotary tables on it, every single movement that this table does, it will check in between tool paths also, and not just while you're doing the overall operation. So really, the simulation is a huge game changer for a lot of the companies out there. And I can honestly say, I think our simulation in Tebis is the industry leader really when it comes to full-fledged inline simulations, not third-party add-on. It is right inside the system as you're programming. You can see all of this, and even Greg, you showed a perfect planning solution with the bushings that you can start doing some of these things ahead of time.
The nice thing too is, like I was saying, for a dual spindle gun drill, you can hold that previous tool in place in the milling head, and that'll be collision checked. So if you are doing a drilling, like I know back in the day we used to do drill and tap cycles on different gun drill machines. I couldn't simulate it, but now with this, you could check it and simulate it. It's really nice.
There was another question, more or less, what kind of machines has Tebis done already when it comes to different styles of gun drilling? Greg, you've been involved in many of the gun drill projects. What are some of the machines that you've worked with?
So we worked with a few different styles, really. Cheto machines, IMSA style gun drills. Worked with a few Taurus style gun drills, things of that nature. But single head, dual head, we kind of across the board there covered a lot. So
across the U.S., there's also a very nice one as well. Unistak is of course there. We see it in a lot of different shops in there. This solution here is really going to bring out the power of these Unistak machines because of the integrated simulation, the feature capabilities, the dual head solution that you showed so nicely towards the end of it. So it's a really powerful solution there. This gentleman also said we don't have a direct gun drill, but a smaller machine. Can this be also used for just drilling deeper holes on these types of machines?
Absolutely. We've actually worked with a few different style boring mill machines here, and I know the biggest concern is can we tell it for that spindle to not turn on and when it's outside of the hole, right? Because maybe you have a pilot hole that's a certain depth. With our options in here, it's absolutely possible. It's actually really easy. It kind of goes back to what I was saying before about standardizing your process when I switch over a machine. If I set it up ahead of time to do that, I can actually pick different tooling. Maybe I want to run a pilot hole, run it on a smaller machine. It's all in the software, ready to go.
Okay. Well, since we still have some time left there because of the multiple questions that came in. There is also another question here in terms of the automation. How automated can you make this process?
As automated as I know how to do it, I guess it's a lot easier than manually programming it. I would
If I
say,
can add to this, Greg, not to jump over you here too, because you've done a lot of these automation. I mean, you've talked about NC sets as
hmm
one way to automate these drills. You've talked about features already in there. The features has all the geometry, all the vectors, all the positions already in it. You have NC jobs inside the system, templates that you can do this. I mean, is it really as easy as just swiping a part, putting the features in, and hitting go?
it can be, yes, and it's all, in my opinion, based on organization and how you set up the features and NC sets in the beginning. So the work, if you put in the work here in the beginning to look at these parametrics, look at the features, not necessarily as you're programming it, but you're setting up that process. Now, in the future, when you're programming those parts, it's just going to be that much better.
Mm-hmm.
So I would say, put the time in, put the effort into making sure that these are very solid. We do a lot of help with that as well. And, make sure it's going to cover across the board what you're looking for. All jobs come in different. So that's always my first question that people ask me. They'll say, oh, I get this job and from this customer and it looks completely different than this job. And that's completely fine. You set up your parametrics just a little bit maybe differently for those different customers, or you could do one that kind of fits across the board. But once you have that set up, it could be really, really simple.
If I can add one more thing to it, you mentioned earlier when you were going through the different menus that it's not just static features that we create, it's all variable features. And variable
Yes.
features really means that it goes out to your tool library and grabs the correct tool in order to do your drilling operations. So you really go into the nth degree of automating where the software automatically selects the proper tool, the proper flute length in order to get all of your drilling operations done. This variable tooling is really a huge deal, and it can really elevate you to the next level. Here's another question that just came in. I'm going to almost go from the bottom up here now. Can you elaborate a little bit more on the advantages of using Tebis on a, for example, boring mill, for example? This gentleman says, yeah, it's a 3+2 head, plus he has a rotary table, almost like an FTP Ronin. How beneficial is this to utilize this on these types of machines on boring mills?
So to start, I would make sure that you have the correct tooling in play. They do offer a wide variety of great tools out there that are able to work with boring mill style machines. Sometimes you can use an old conventional gun drill too, but it really just depends on how you want to machine it. But the benefits that I would see on running something on a gun drill versus maybe waiting for a gun drill to be open, or maybe I don't have one, I got to outsource it, is going to be not having to send it to a different machine. You're going to be able to utilize, okay, what if they missed a water line or there's an engineering change and I have to machine a pocket and maybe just one water line or a vent hole, or you got like a hot form die, maybe you want to utilize that a little bit. You're able to get that done on a machine that maybe is available a little bit quicker. So really, it's just aiming for a solution that's going to all around get your job done a little bit faster or more efficiently. That's my opinion. I think it's great. I think you can utilize them on different boring mill style machines. Absolutely. The features, NC sets, and things like that, it's not specific to a gun drill style machine. It's more or less in the software. So.
Well, there's lots of great different types of boring mills already out there. He mentioned that this gentleman has an FTP Ronin that he's utilizing, a really great machine for milling types of operation. And as we know, a lot of the 2D is not just drilling. It's not just regular drilling operations with tapping and drilling operations, but also huge milling operations with pockets and stuff like that. So these types of boring mills are really laid out for a lot of this type of operation. And there's great tooling, like you said, out there that can handle a lot of these deep hole kind of drilling. Now, just to add on this, with cooling codes, are those cooling codes inside the post processor, or can they be varied by the user who's actually doing it, depending on retracting or all those kind of things? Because you talked about the table for the parameter tables and so forth. Elaborate on that.
So the cooling codes are called out inside of the parameters in Tebis in the software as you're programming. So
Mm-hmm.
if I go through and I start programming a job, I could even set it up per gun drill if I'd like to go that far. I think you should if you're going to standardize your process. You could set up different conventional style gun drills and regular gun drills. You could even set up different processes to say, I don't want the pressure to be all there, but maybe I just want to lower the pressure. We can even do that as well. But you set it up inside of the software as you program. And it's even really easy to change on the fly. Like maybe you say like, okay, I'm on a boring mill style machine. When it comes out of the hole, I want to turn everything off, air, coolant. So you could just say, you could turn all that off as you're programming it. But yeah, you do all that ahead of time.
If I want to add one more thing to the question that was asked earlier about the automation, and I can plug out, Tebis has really put a lot of thought in regards to automation, especially during this time of, well, COVID, as we're all sitting here in either our home offices or at work, separated by 6 feet of distance. Um, Automation is really the heart of all of this. And with our automation package that we have created, we've put a lot of thought into this of every single scenario that can happen for your drilling operations or even milling operations. And we went above and beyond to even to what maybe you can do or you've learned throughout training, where we have solutions in there that covers pretty much every single scenario. If you switch from machine to machine, the software automatically recognizes it, changes the strategies to automatically adapt to the horsepower or the capabilities of your type of machine. So if you're dealing with your representatives, if that is in the UK or in Sweden and Germany or here in the US, contact our office. We'd be happy to talk with you about these automation capabilities. These are already predefined templates that we've created. They can be customized even more to your definitions and your liking, what you want to have. And then we can really automate this entire process and make it really as easy as can be. Hopefully you've agreed with us that this solution is really easy and really easy to use. It is part of our 2.5D solution in there with the MDeep solutions in there. So please, I would say give us a call, give us an email, send it to us. I need to address this. There's one little mistake. In case you're going to drive to our office and utilize the address that is posted on the very bottom of this PowerPoint, it is not 40 East Big Beaver, it's 400. So my mistake. I live up to it. It was my fault. I missed 10, which of course is very detrimental. Anyways, since there's no more questions coming in as we speak here, I hope that you guys have enjoyed this webinar. We hope that we have intrigued you guys to say, you know what, maybe we need to give Tebis a look when it comes to this gun drilling operation. Contact us at our office, call us. Also contact my good friends over in the UK with my good friend Paul Scally or my teammates over at our headquarters at Tebis AG in Germany or even Sweden with my friend Per. So please contact the various different sister companies or distributors with questions, bombard them with questions in regards to this gun drilling capability, and really test it out for yourself. It is really easy to use. Look at this technology package, and hopefully this is going to benefit you, especially throughout this pandemic that we're still running through, and automating your processes really to the extent. With that said, I personally want to thank you for this time. We have roughly about now 50 minutes that we've covered. Again, if there's any questions afterwards, send it to us directly, either to myself or to our info box. And yeah, with that said, I wish all of you guys a wonderful time still in December. Stay safe out there wherever you are. And hopefully we make it through this very difficult 2020 year. And I wish all of you guys a very good breach over to 2021. And we will hopefully see you soon at our next Tebis webinar that's going to be coming up shortly. So check your emails and check our listings of when our next webinars come up. With that said, I want to thank you and wish you all a good day.
Thank you guys. Have a good one.